Okay, so if you're still kind of lost with binary, I'd encourage you to go back and look at those videos again and just make sure you understand how it all works. We're going to now transition to hexadecimal. So hexadecimal is base 16. Okay, and what that means is we count from 0 to F. Zero to 9 is pretty normal for us. A is 10, B is 11, C is 12, etc. Okay, and so in the hexadecimal system, it's base 16. So each place value is worth 16. I don't know a better way to say that, but the first place value is the ones. The next one is the 16s. I believe the next one is the 256, and on and on and on. So you convert it very similarly to what we saw with binary or decimal. So if you have the hex number, hex 24, it's 1 times 4, 16 times 2, you get 36. And if we have the hex number 1D, well, it's D times 1, which is 13 times 1, and 16 times 1, and we get 29. Okay, so you might be thinking, well, why are we doing this, right? Okay, let's jump back a step. So just so you could see the decimal number and then converting that into a hex number. And what you should notice is that we're using less characters. So a 3-digit decimal number is now represented with 2 hexadecimal characters. And if this is binary, this would be, I think it would be 16 binary ones and zeros. So we're doing this to conserve space, to make things a lot more readable and easier to analyze. Okay, every byte, 8 bits, is 2 hex numbers. Okay, so we go from 8 bits, 1 byte, down to 2 hex numbers. All right, and so here's just a few more conversions if you ever have to convert. All right, you've got hex 13 is 1 times 16, 3 times 1, and you get 19. Hex 310, or I should say hex 3A, is 3 times 60, 10 times 1, and you get 58. Hex A4 is 10 times 16 plus 4 times 1, 164. Hex FF is 255. Okay, so again, why are we doing this? This is to be efficient. So I have a hard time just looking at binary ones and zeros and knowing what that is. But if you take that binary and convert it into hexadecimal, I can actually read that because it's more efficient and it maps to English letters much more easily. Okay, and we humans, we just have difficulty with binary, but hexadecimal is a lot easier for us. It's kind of like a shorthand for our binary system. All right, so where would you actually use any of this kind of stuff? Well, if you were programming in BASIC or assembly language, you would use hexadecimal. Sometimes you may have seen this in error screens or something. You have a memory error at hex F95C. You probably have seen color codes in websites as 0000FF. That's all hexadecimal. Or maybe you know that your MAC address is written in hex, 6 hex numbers. 6 pairs of hex numbers. Okay, so if you pull up a ASCII keyboard chart, you could convert your name into hexadecimal. We're not gonna do that right now, but that'll be fun for you. All right, so hopefully you kind of have an idea now about what hexadecimal is. And I can just tell you, in security, we use this a lot because we see packets of data. If you're using a tool like Wireshark or TCP dump, you see packets of data and you see hexadecimal on the screen, and it's helpful if you can read the hexadecimal. And it's a skill that I've started to develop. So I can look at certain packets of data and go, okay, this is a TCP packet, and there are no options on this packet. And it helps you to analyze what's happening right in the binary or hexadecimal code. So we'll take a look at this maybe a little bit later, but hopefully this has helped you as you try to convert hexadecimal into decimal or binary and back and forth. If you take AP Computer Science, this is a skill that you will need. So there's that too.